Let us talk about the most important aspect of the execution plan, that is order of operation. Order of operation basically means which operation will execute first, followed by the rest of the operation. Understanding the order of operation is extremely important because it helps us to compare the way we want Oracle to execute the query is matching with how the Oracle has actually executed a query. There are two ways by which we can determine the order of operation. First is by creating a parent-child relationship. It is basically a lengthy process to identify the order of operation using the parent-child relationship. Second is by directly reading from the execution plan with the help of the indentations. Now the first method basically determines the order of operation by using the parent-child relationship. In a parent-child relationship, parent operation usually cannot be started until its child operation has been started. Basically, it means once all the child operation gets completed, only then the parent operation can execute. Now, if there are multiple childs for a parent operation, the first child listed in the execution plan will always execute first. Second method to determine the order of operation is by reading the execution plan directly inside out, starting with the most indented operation. Using this method, the first operation that will be executed is the one that has the most indentation and is also the topmost and the innermost child operation. If two statements appear at the same level of indentation, the top statement will execute first. Now let us see in more detail about the order of operation using an example. In this example, we will see how to read an execution plan or to determine the order of operation using a parent-child relationship diagram. This is a very simple example of join between the two tables, that is employees and the departments, where d.department id is equal to e.department id and e.employee id is equal to 100. When I execute this query, Oracle has generated this execution plan and it has got 5 operations ranging from 0 to 4. Now, in order to determine the order of operation using a parent-child relationship tree, what we will do is we will take the first operation, that is 0, and we'll write it as the parent operation. Now operation number 1 is indented towards the right side, so 1 automatically becomes the child of 0. Now operation number 0 doesn't have any other child apart from 1. This you can confirm by noticing that there is no other child operation which has the same indentation as operation number 1. So if you see on the same level as 1, there is no other child. So 1 becomes the child of 0. So we have written 1 as a child of 0 under the select operation. Operation number 1 is your nested loop. The next operation number 2 is indented on the right side of 1. So operation number 2, that is table accessed by index row id, becomes the child of 1, that is the nested loop. You can also see the operation number 4 is on the same level as 2. So operation number 4 is also the second child of the nested loop operation, that is operation number 1. But since 2 is on the top and 4 is on the bottom, we have written 2 on the left hand side and 4 on the right hand side, that is index unique scan operation. The last operation which is left is operation number 3. Now if we see, the operation number 3 is the child of operation number 2 because it is indented towards the right of operation number 2. So 3 becomes a child of 2 and we have written 3 operation number which is using unique scan emp underscore id underscore pk, and we have written 3 under operation number 2. You can also see the below predicate information. Operation number 3 is doing an access on e.employee equal to 100. That means it is basically fetching this, that is e.employee equal to 100. And we also have operation number 4, which is again the access on d.department id is equal to e.department id, which is nothing but the join operation between the two tables. Now in order to read this parent-child relationship tree to identify which operation will execute first, you have to look at this parent-child relationship tree from bottom to top and left to right. Now if you see from bottom to top, operation number 3 is at the bottommost. And if you see from left to right, you will see the operation number 3 matches the criteria. So if you look from bottom to top and left to right, operation number 3 will qualify as the first operation. that will be executed. So operation number 3 will execute first, which is nothing but index unique scan on the employee ID underscore pk index. If you see operation number 3, this is the access on e.employee ID equal to 100. So Oracle has first executed e.employee ID is equal to 100. Once the operation number 3 is executed, now 3 is the child of operation number 2. So once 3 is executed, 2 will execute. Operation number 2 is nothing but table access on the employees table. So operation number 2 will execute. Now table access by index row ID basically means it will try to access all the desired rows of the employees table which matches the criteria e.employee ID is equal to 100. Now if you see in the select statement, Oracle is accessing e.department ID. That is, it wants to access the department underscore ID column from the employees table. Now since we already have employee ID equal to 100 being accessed, Oracle will go and see what the value of department ID is for employee ID is equal to 100, and that is why we see table access by index row ID operation over here. Now once 2 is executed, operation number 1 should execute, but in order to execute 1, its child, that is operation number 4, should execute. So after 2, operation number 4 will execute, and operation number 4 is nothing but index unique scan on department underscore ID underscore pk, and if we see the access predicate for the operation number 4, it is nothing but the join operation, that is d.department ID is equal to e.department ID. Once operation number 4 is executed, operation number 1 will execute because both its child, that is 2 and 4, is executed already. So operation number 1 will be nested loop join between the employees and the departments table, and once the join is completed, operation number 0 will execute, that is nothing but the select clause. So all the columns in the select clause, that is e.department underscore ID, will be fetched. So this is how we read the order of operation using the parent-child relationship diagram. Now this of course is a very lengthy method when the execution plan gets very huge. So we will explore the second method to read the execution plan very quickly. We'll straight away look into this execution plan and we see the first operation is 0. Now 0 is the parent and 1 is the child of 0. So without 1 getting executed, 0 will not execute. So operation 1 should execute. But operation number 1 has got two child, that is child number 2 and child number 4, because both of them are indented on the right side and at the same level as operation number 1. Since 2 and 4 are the child of 1, and since 2 is on the top and 4 is on the bottom, operation number 2 will execute first. But 2 is now the parent and it has a child, that is operation number 3. And there is only one child for operation number 2, that is operation number 3. So since this becomes your topmost and the innermost child operation, operation number 3 will execute first. And that is what we have seen using the parent-child relationship tree. Operation number 3 is the one which will get executed first. Once operation number 3, that is the child operation, is executed, its parent, that is operation number 2, will execute. Again, if you see the parent-child relationship tree, after 3, operation number 2 has executed. Now 2 is the child, its parent 1 should execute, but in order for the parent operation 1 to execute, both its child should execute, that is 2 and the 4. So after 2, operation number 4 will execute. If you see the execution plan using the parent-child relationship, operation number 4 is getting executed. So after 2, operation number 4 will execute it, and once both the child, that is 2 and 4, is executed, operation number 1 will get executed because it is the parent for both of them. Now 1 is the child and 0 is the parent for the operation number 1. So after 1, operation number 0 will get executed. So this is how you can quickly read the order of operation by determining which operation is the topmost and also the innermost operation. In this example, operation number 3 is the topmost and the innermost child operation. We will see some more examples of reading the execution plan using the second method in the forthcoming slides. Now let us look at the example 1 and determine what the order of operation will be using both the methods, that is by creating a parent-child relationship tree and also by using the second method. If we look at this execution plan, operation number 0 is the starting point and it is the parent, so we have written 0 on the top. Now 0 is the parent and 1 is the child, and operation number 0 doesn't have any other child apart from 1 because there is no other child operation on the same level as 1. So we have written 1 below operation number 0. Now operation number 1 is the parent and it has got two child, that is 2 and 5, because they are on the same level. But since 2 is on the top and 5 is on the bottom, we have written 2 on the left hand side and 5 on the right hand side. The only operation now left is operation number 3 and 4, and since operation number 3 is the child of operation number 2, and since 3 is on the top and 4 is on the bottom, we have written operation number 3 on the left hand side of 2 and operation number 4 on the right side of operation number 2. Now if you want to read the order of execution, we have to look at this parent-child relationship tree from bottom to top and left to right. Now if we see from bottom to top, 3 and 4 both will qualify as the first order of operation, but if we look from left to right, operation number 3 will qualify as the first operation that will get executed. So 3 will execute first, and then operation number 2 should execute. But in order to execute 2, we need operation number 4 also to be executed. So after 3, operation number 4 will execute, then operation number 2, and then operation number 1 should execute. But in order for operation number 1 to execute, its child, operation number 5, should also be executed. So after operation number 2, operation number 5 will execute, then operation number 1, and since it has got only one parent, that is 0, after operation number 1, operation number 0 will get executed. So this is how you read the operation using the parent-child relationship tree. Now using the second method, we can quickly reduce the order of operation by directly looking into the execution plan. So operation number 0 is the parent, 1 is the child of operation number 0, and it doesn't have any other child. Now operation number 1 is the parent and it has got two child, that is 2 and 5. Now since 2 is on the top and 5 is on the bottom, operation number 2 will execute first. But since operation number 2 is again a parent and it has got two childs, that is 3 and 4, and since 3 is on the top and 4 is on the bottom, operation number 3 will get execute first. And we see from the parent-child relationship tree also, operation number 3 has executed first. Once the first child get executed, the second child will execute, that is operation number 4, because both of them are on the same level. So operation number 3 will execute, then followed by operation number 4, and once both the childs are executed, the next parent, that is 2, will execute first. So order of operation till now is operation 3, operation 4, then operation 2. Now after 2, 1 should execute, but there is another operation called as operation 5, which is on the same level as operation 2. So after 2, operation 5 will get executed, then operation 1, and then operation 0. So this is how you can quickly determine the order of operation using the second method. Now let's take another example to understand the order of operation. First we'll determine using the parent-child relationship tree. So 0 is the parent, we have written it on the top. Now 1 is the child of 0. Operation number 0 doesn't have any other child apart from 1 because there is no other operation on the same level as 1. So we have written 1 below operation number 0. Now 1 is the parent and it has got two childs, that is operation number 2 and operation number 6, because they are on the same level. Now since 2 is on the top and 6 is on the bottom, we have written 2 on the left hand side and 6 on the right hand side. Operation number 2 has two childs, that is 3 and 4. But since 3 is on the top and 4 is on the bottom, we have written 3 on the left hand side and 4 on the right hand side. Again, operation number 4 is now the parent and its child is 5. So we have written 5 under operation number 4. The only operation now left is operation number 7, and operation number 7 is the child of 6. So we have written 7 under operation number 6. Now in order to read the execution plan, we will look at the order of operation from bottom to top and from left to right. If we see from left to right, operation number 3 is the only operation that qualifies. So operation number 3 will get execute first. Once operation number 3 is executed, operation number 2 should execute, But in order to execute operation number 2, both its child, that is 4 and 5, should execute. So after operation number 3, operation number 5 will execute, then operation number 4, and then operation number 2. Once operation number 2 is executed, its parent, that is operation number 1, should execute. But since 1 has further childs, that is 6 and 7, so after operation number 2, operation number 7 will execute, then operation number 6, and then operation number 1 will execute. Once 1 is executed, operation number 0 will get executed. Now using the second method, we can directly read the order of operation from the execution plan. Operation number 0 is the parent. It has got only one child, that is operation number 1, so 1 should execute. But 1 is the parent again, and it has got a child, operation number 2 and 6 on the same level. Now since 2 is on the top and 6 is on the bottom, operation number 2 will get executed first. Now 2 is again the parent, and it has got two childs, that is operation number 3 and operation number 4. Now since 3 is on the top and 4 is on the bottom, operation number 3 will get executed first. Now operation number 3 doesn't have any other further child, so operation number 3 becomes your topmost and the innermost child operation, and that is why operation number 3 will execute first here. Once the operation number 3 is executed, its next child, that is operation number 4, should execute. But since 4 has a child, that is operation number 5, so after operation number 3, operation number 5 will get executed. After 5, operation number 4 will get executed. Now since both the childs 3 and 4 is executed, the operation number 2 will get executed. Now after 2, operation number 1 should execute, but in order for operation number 1 to execute, it needs both its child, that is 2 and 6, to be executed. And in order to execute operation number 6, its child, that is operation number 7, should get executed. So after operation number 2, operation number 7 will get executed, then operation number 6, and then operation number 1 will get executed, followed by operation number 0. Now let us look at another complex example of order of operation. Here also we will use both the methods. First is we will create the parent-child relationship tree. Operation number 0 is the parent. We have written operation on the top. Now operation number 1 is the child of 0, and 0 doesn't have any other child apart from operation number 1. So we have written 1 below the operation number 0. Now operation number 1 is the parent, and it has got again only one child, that is operation number 2, because there is no other operation on the same level of indentation as operation number 2. So we have written 2 below the operation number 1. Now operation number 2 has got two childs, that is 3 and 4. Now since 3 is on the top and 4 is on the bottom, we have written operation number 3 on the left hand side and operation number 4 on the right hand side. Now operation number 4 is the parent, and it has got one child, that is operation number 5. So we have written 5 below operation number 4. Similarly, operation number 5 is the parent, and it has got one child, that is operation number 6. So we have written 6 below operation number 5. Now 6 operation has got two childs, that is 7 and 8. Now since 7 is on the top and 8 is on the bottom, we have written operation number 7 on the left side and operation number 8 on the right side. Now in order to read the order of operation, we have to look at this execution plan from bottom to top and left to right. Now if we see from left to right, operation number 3 will get executed first. So operation 3 will get executed, followed by operation number 2. Now in order for operation number 2 to execute, all its child should execute first, that is 4, 5 and 6. Now in order to execute 4, it has to execute 5 first. In order to execute 5, it has to execute 6 first. And in order to execute 6, operation number 7 should execute first because it is on the left hand side. So after 3, operation number 7 will execute, then operation number 8, and then operation number 6, then 5, then 4, and then 2, followed by 1 and 0. Now using the second method, if we directly look at the execution plan, operation number 0 will execute first, but it has got one child, that is operation number 1. So 1 should execute. Again, operation number 1 has got one child, that is operation number 2. So 2 should execute. But operation number 2 has got two childs, that is 3 and 4, And since 3 is on the top and 4 is on the bottom, operation number 3 will get executed first. Now 3 doesn't have any other child, so operation number 3 becomes your topmost and the innermost child operation. So operation number 3 will get executed first. After operation number 3, operation number 4 will get executed because they are on the same level of indentation. But in order to execute operation number 4, it has to execute its child, that is 5, and then 6. And operation number 6 has got two childs again, that is 7 and 8. Now since 7 is on the top and 8 is on the bottom, operation 7 will execute. So the order of operation is operation number 3 will execute first, then operation number 7, then operation number 8, then its parent 6 will execute, then its parent 5 will execute, then its parent 4 will execute, and once 4 is executed, operation number 2 will execute, then operation 1, and then operation 0. So this is how you can read the order of operation using the second method in this example.